All right, welcome back. This is part three. And when I last left you, we were back on a slide that not updating, not selecting multiple rows within a procedure. So we talked about that SQL, PL SQL, can process only one record at a time. So that's not very helpful in most cases because in most cases we've got data. We want to process multiple rows. So how do we do that? Well, this is where we get back to utilizing some stuff built in, and this is where we're going to utilize cursors. So cursor is a pointer to a row in the collection of rows retrieved by a SQL command. The cursor advances one row at a time to provide sequential one record at a time access to retrieved rows. That's how we get back to this ability to only process one row at a time. We do that by having a cursor that takes these rows of data, points to one, and allows the PL SQL to just use that one row at a time. And then we can move forward, and we can move forward, and move forward. Now, real quick, right off the bat, some things that you need to know is that the first step to clear a cursor is to describe the associated query in the declaration section. So here we can see what we're doing here. We're saying cursor, and we're seeing what the cursor name is, and then our query. So cursor customer group is select customer number and customer name from the customer table, where rep number equals that IREP number, which is the input number. To do this, three commands are needed: open, fetch, and close. So the first thing we're going to do with that, so we've set up, let's go back, we've set up our cursor, we've defined our cursor, I should say. Now we're going to open our cursor using the open command, which opens the cursor, causes the query to be executed, and makes results available to the program. Please note that prior to the opening, there are no rows available to be fetched. So here's an example of open customer group. The other thing I need for you to know is when you open a cursor, the pointer is actually pointing to, well, it's not even a row. It's pointing to before the first row. Always remember that. It always starts out by pointing right before the first row. And there's a reason for that. And we'll talk about that here in a moment. But remember that. First row. So here is kind of, we're opening a cursor. And we're showing it this customer group has this customer name and this customer number and this customer name. And then we're saying, hey, customer number is 126. So what happens when this row set is attached and we start using the fetch command? Now, unfortunately, this slide doesn't really make a whole lot of sense. So let me jump to the next slide and talk about that first, and then we're going to go back, right? So the fetch command advances the cursor to the next row in the set of retrieved rows, places content of row in the indicated variables. So the fetch cus group, which that's the name of the cursor, into customer number and customer name. Now remember, in our original query, where did it go? We said select the number and the name. Okay. And here we said the customer name and number and the name. So when we do the fetch, what happens is if we say 126, it's going to put, when we use the fetch, it's going to say, hey, fine, I'm going to put the toys galore, because it's on the 126, into the iCustomer name. And it's also got this variable out there that just exists that we can make use of, and it's called the not found. And what it's saying is, if there's another, when it fetches and it goes to the next row, if there is more data, it will say false. Not found is false. Yes. And if there is not more data, then not found would be true. So always remember, when we do the open, at first, I wish I had my pen device with me right now. At first, it's actually pointing to before the first row. We're going to then do a fetch, which will make it point to the first row. It's going to fill in all the information, 126, the toys of galore. These are the variables we've asked it to fill into. And it's going to say, hey, not found is false, because that means it found a row, and here's the data. If we do fetch again, because this is the data that came back for whatever reason, I'm not sure why this data came back, because it's not part of like 126 or anything like that. But let's just say that this is the data that came back into the for the cursor to use. So when we first say fetch, it goes to 126 toys galore. Now we're going to do the next fetch. So it's now going to take 502 and cards and more and shove that into our variables. Again, it's going to say false because there is another row of data. There's a row of data. At some point, when it gets to the end of executing, it's going to tell us that there's no more data to be fetched. So here is 893. So this is just us kind of going through. So this is what happens when we say this. When we say fetch, it puts the next row of data in there. It then pushes the cursor to the next column, to the next row. We do it again. Now it's 893. It's 713, and then advances to 893, and then at 893 all seasons gifts. You'll see 893 in all season gifts and false. And the reason being it says false. Now you might have thought, okay, this should have said true because there's no more data. This will say true when it can no longer put data into the variables. Because this fetch, when we said fetch on this, and it advanced to this 893, and then we called fetch here, it fetches the data that it's currently pointing to, 893, all seasons, and then false. Now it's pointing to this column, this row, which does not exist. On this next fetch, it's going to put no data and then true. So, I'm sorry, it leaves, that's right, it does leave the previous data, but that's why it changes this to true. So what really is happening behind the scenes is there's no data to fill these variables, so it doesn't. It just leaves it with the old data, and then it changes this to true. And this is telling you that there's been no more data to retrieve. What's important about this is you want to check this not found first. If it says false, then you can use the data in your variables. If it says true, don't use the data in your variables because you've ran out of data. This is old data. True tells you stop, you're done, you can move on. Once we've done that, when there's no more rows to fetch, go ahead and close out your cursor. Now let's see how that looks all together. I know I said an awful lot. This will make it a little bit more understandable. Let's talk about it. So create or replace our procedure. Our name is display rep customer. We're taking an input of rep number, which is the type of rep number for this rep table, same type. We're going to go ahead and before we start our actual store procedure, we're going to set up our variables. iCustomer number is of the type customer number from the customer table. And iCustomer name, same thing. It's the customer name type from that customer table. Here's us declaring our cursor. A cursor is a variable that holds on to the SQL statement. So cursor, cus group, is, and then our SQL statement. Select customer number, customer name, from customer where rep number equals I rep number. Now, and so that's why that's why we had multiple data, because it wasn't searching on the customer number, it was searching on the rep number. So all of this data is the same rep number. That's why I was doing it. Sorry about that. I'm glad I was able to figure that out as we're going through the actual narration of all this, right? So that's what's going on. So the rep number. So this could return, and it will return usually more than one row. Okay, we've now declared our variables, we've declared our cursor. Now we can begin our store procedure. Remember, the first thing we got to do is open. Open actually runs this query and then stores the data into this cus group cursor. Next, we're going to use some SQL stuff that allows us to loop through that customer. So we're going to say loop, and by the way, we always end our loops with end loop. Remember what I told you, when you open a cursor, it does not point to the first row of data. So you have to fetch customer into iCustomer. So you're always going to call fetch first. It doesn't already have data loaded. You need to call that fetch first. Cus group into iCustomer number and iCustomer name. So we're telling it to take the customer group cursor, fetch that data, and shove it into these variables for us. Now that we've done that, let's just make sure that we haven't ran out of data yet. So we're going to say, hey, exit when that cus group % not found. So again, when this is true, it's going to exit. So we fetch, then we check. If we're not out of data, then we can do something with that data. And that something should be right below the exit and still within our loop. So in this, we're just outputting that name. What then happens is the loop ends, control is returned back up to this beginning loop. It does the next fetch, which it moves forward one, takes in that information, fills in the cust groups not found variable, whether it be true or false. Then the next line checks. If this is true, it exits out of the loop. If it's false, it will let the execution continue through the loop. Once this keeps happening, at some point it's going to hit that true, and it's going to exit out of this loop. Exit does not exit out of the store procedure because it's in a loop. If an exit's in the loop, it's going to actually exit the loop. Now that we've done our open, we've done our fetch, remember our third and final, which is to close cus group. We want to close that cursor. And then in this case, we're ending the store procedure with our little slash. This is now us using that. So remember, it was display rep customer. So we're saying begin. Remember, to use a store procedure we've created, we have to still do the begin, end, and slash. And then in between, we're going to make use of the actual store procedure name, display rep customer 15. Here you go. As you will see, all 4 lines will be outputted correctly. Using more complex cursors. Any SQL query is legitimate in a cursor definition. More complicated retrieval requirements result in greater benefits. That kind of makes sense. So let's take a look at this one. Let me blow this up. We may have to scroll a little more, but again, this is pretty intense. So here we're creating a replacing procedure called display item orders. We're taking an input of item number, which is the same type as the items table, item number column. We're setting up a bunch of variables, which is we got order number, we've got order date, the customer number, the rep number, the last name, the first name. And these are going to be the reps, last name and first name. Again, for me, I would probably put I rep last name, I rep first name, but that's just me. Cursor, we're creating that cursor, which is called order group, now look at this query. It's a pretty, not intense, but definitely detailed, right? So we're selecting all these columns from order line, orders, customers, reps. So we're actually doing a join with 4 tables where order line, order number equals the order's order number, and that orders.customer number equals customer number. So you should see as these ands are putting together the joins. We've done all that, so now we're ready to make use of that data. We can actually write our store procedure now. So we're going to hit the begin, because remember, begin tells us that the store procedure is coming. We're going to open our cursor here. So now this query is being executed, and then we're going to sit in a loop. The first thing we always have to do in the loop is fetch the next piece of data. Order group, and we're going to put them into our nicely developed variables from the top. Always want to do that exit when order group's not found. So, hey, you know what? If we run out of records, stop the loop. And in this case, we're actually going to put on the line each item, each piece of this data on its own item. Then we're going to end the loop, which means, hey, go back up to the loop, start again. If you hit the true when we're out of data, go ahead and exit this loop. Finally, we're going to close off that cursor. So it's really important. End semicolon and our slash. And I don't think it shows us, sadly, what the output is. Maybe I should, for future classes, kind of just put this in, make a slide out of what the data actually looks like. All right, so let's go back and talk a little bit more about cursors. So this is the advantage of the cursors. It simplifies coding in a program because we're putting a pointer on top of a record set. Programs with embedded SQL utilize the optimizer. SQL has a way, Oracle and SQL actually have a way to look at your cursors and find ways to optimize that data. Programmer doesn't have to worry about the best way to retrieve data. The program doesn't have to change, even if the underlying structure does. So those are definitely some advantages of cursors. Cursor definition only changes, not the procedural code. So again, if we come up here to one of our maybe a little bit more simple queries, what they're saying here is if the table changes, we only have to, let's say, customer number, somewhere, somehow, somebody got the idea. We shouldn't be calling things numbers, right? It's not descriptive enough. We want to change that all of our num columns to ID columns. So now it's customer underscore ID. But once that happens, all I have to do is change the cursor here, and everything will go back to working the way it should, right? We only have to change that because all this is built off of the cursor's definition. So if I just change this to select customer underscore ID, well, it's still going to shove it into this customer number variable. I don't have to go and change that variable name. Some companies say, well, for consistency, we should, right? But you don't have to. And that's one of the convenient things about a cursor. Turn down the blowing up of data. So there you go. Using T-SQL and SQL Server. So we've been talking about PL SQL in Oracle. Microsoft SQL uses T-SQL, which you're going to find out, and it's also known as Transact SQL. It's an extended version of SQL. T-SQL and PL SQL are very similar for the most part. There are minor differences. Usually, if you know one of them, a lot of people know T-SQL and or PL SQL, but on occasion need to write the opposite. It doesn't take much to do some Googling, like the date function. Those are slightly different in T-SQL and PL SQL. So you might have to Google, hey, how do you do PL SQL's version of date diff, right? And that will tell you how to use that. And in this is going to be, we're going to go through this fast because this is exactly what we just learned in our stored procedures, but doing it through Microsoft SQL. So with that, and you'll notice that there are some catches, some differences. And the big difference is back in our PL SQL, we could tell it, hey, create a new one or replace. Unfortunately, in SQL, the first time you set up a procedure, you have to say create procedure, the procedure name. And our incoming arguments are going to be represented with this @ sign, as you can see there. And there's no type going and using an existing type from a column. You have to just know what that column's type was or whatever type you need, and you physically have to tell it char2. As, just like in all the other things, we always have that word as out there. T-SQL does the same thing. And then here is your SQL store procedure. Select rate trim first name. Remember, in Microsoft SQL, we don't use two pipes. We use plus signs from rep. And then to do this, we're going to make use of the word execute. A little less work to actually use the store procedure. We don't have to do begin and end on this. We can just execute use display rep number 20. There should be a space, by the way. A lot of times, companies will also make use of parentheses around that. You don't have to, but it is possible. So here is data. Here's another example of an update using Microsoft SQL. We're creating the procedure. Here's the procedure's name. Again, once we've created this, if we need to change something in here, instead of what you'll do is you'll get a hold of the store procedure code and you'll change the word create to alter, and that updates the procedure rather than create the procedure. We've got customer num char 3, customer name char 35. This is our incoming variables. We're updating the customer table. We're setting the customer name to this new customer name where the customer number is customer number. And again, to execute, we're going to type in the name here. There is supposed to be a space there. 260, comma, Brookings Family Store. This is going to change customer 260 to this new name. In SQL, we're going to have the ability to do delete with store procedures. Again, we're creating a procedure. This is the procedure name. We're taking in one variable, that's the char 5. And then we're saying as delete from order line where order number is order number. Remember, we got to get rid of the lines out of the order line table first. And then we can do the delete from orders where order number equals the order number. When you are using SQL, we can use a cursor, create procedure, display customer, our incoming variable. We're declaring some variables up front. So this is why we use the declare statement in SQL. So we're declaring some variables. We are making a cursor. And in SQL, we have the option to mark it as read-only, which actually makes the cursor a little faster because it knows it doesn't have to worry about taking in updates. And the for statement is saying, hey, this is the query right here that's going to be represented by this cursor, my cursor. And then wouldn't you know it, just like PL SQL, you got to open your cursor. Then we're going to fetch next from my cursor into our variables. So similar process to the PL SQL where we're shoving data into variables. And then we're saying while at fetch status equals 0. This is Microsoft SQL's way. It's the same thing as way back up in here where we said exit when customer not found, but in SQL terms, I skipped it. In Microsoft SQL terms, we use the fetch at fetch status equals 0. And this is saying keep doing this while this is 0. And then we do the begin and end. Microsoft SQL, instead of using that DMVMS package, we're doing the print, and we are just concatenating data. And then we're fetching next from my cursor into those things, and we're closing that end loop. And you'll keep doing this until it's done. And then we're closing the cursor. One additional thing you have to do in SQL is you have to deallocate the cursor. And that's because even though you close the cursor, the memory that's being used for the cursor is still being used. It's not even accessible, really, but it's still there. Nothing has kind of marked it as free to use again. So that's why in SQL you have to deallocate it. Okay. So this is kind of just what we just talked about. Declare variables, declare cursor, select the statement, open the cursor, fetch it while close, and then deallocate. Kind of just went through that. Again, now we're going to go even faster because this is just for your edification. For the test, there is no homework. Well, actually, I think there might be something in the homework, but I'm not. Again, we're more focused on the Oracle piece. So in the SQL, Microsoft SQL in Access, programs are written in Visual Basic. Does not allow inclusion of SQL commands in the code. If the SQL command is stored in a string variable, use the do command run SQL. So what this is basically saying to you is that you're basically going to construct a SQL statement as a string. That's what we're doing here in this Visual Basic module. We're making the actual the command, the delete from rep, where rep number equals the incoming. So we concatenate the previous SQL string, which has this in it, and the irep number. And then we're doing that again. We're now taking this, everything here, taking that and adding that in parentheses, and then we're running the command on the run SQL. So when we do this, we can run the code normally by calling it from another procedure or associating with an event. It can be run by using the immediate window, which is somewhere down here that it's not showing us. But normally it's used for testing. Again, Access is a lot more limited, and so it can. Here's that immediate window, by the way, that was below that they cut off before. But again, most of your companies now are moving to something more professional like SQL or Oracle. Don't want to get too much into this. It's updates. As you can see, we're doing an update just like we would before, but it's a very simple update statement that we're utilizing and then running on the SQL. Same thing with inserting data. You process similar, create the appropriate insert commands with a string SQL variable. You have multiple arguments and insert the data, one value each inserted. Finding multiple rows with Visual Basic. So SQL commands handled differently than pSQL. There's no cursors, unfortunately, in Access, and you handle results of query just as you would use a loop. So again, part of that's because Access uses Visual Basic. We don't really need to set up a cursor. That's already kind of done behind the scenes for us. So here's our statements. This is us creating some variables to do what we need to do. Here is our SQL command. We're actually using the open. We're telling it that we want to open this string SQL. We're using the AD open static, which is the way we open up our SQL command, and this is the command up here. There's a lot of stuff up here that you have to bring together in your open command, and then this is the same thing as what we saw before, but we don't actually have to use a cursor because the RS, which is this, actually is a cursor for us as well. So as we're opening this connection and using that connection string, it's actually going to make kind of a cursor for us. So we're going to do until the rs.eof, which is in the file. So as long as there's records, it will continue to not tell us that it's in the file. When it does, it means we've ran out of data, and we'll stop doing the loop. In this, we're going to do a debug print, which is similar to that DBMS output where we were doing in Microsoft SQL. We did a print. And then RS move next. Now, interesting enough, when you open RS, it's already pointing to the first row of data. That's why before we used to have our fetch at the top and then we did stuff. Now we do stuff and then we move next. And then loop tells us that's the end of the loop. It'll come up here and try again, keep going until it hits that end of file. And that is the end of the function. All right, so that is the end of how to kind of create store procedures and the different methods. Actually, this is more about the cursors. Most of this was about cursors and how to utilize cursors in store procedures. We're going to go ahead and, because it's only really a couple slides, we're going to talk real quick about triggers. Triggers are procedures that is executed automatically in response to an associated database operation. It basically is a store procedure that's triggered on actions from our database management system. So we can create the trigger like we've just like we've done everything else. We've created tables, we've created procedures. Now we're going to create a trigger. We're going to put some SQL commands between begin and end, and we're going to specify using new or old what was done. So the new is going to refer to the row of data that was added, where the old shows what was deleted or updated. So, for example, if we're doing an insert, new is going to have the new row, right? If we're doing an update, old is going to show us what was there, and the new is going to tell us what is now there, the new thing we've updated. So here's a trigger, just like previous, create or replace trigger, add order line. So it's saying after the insert on order line for each row. Now that's a statement on its own, right? So it's saying for each row, after the insert on this table, do this. So the way it looks actually in Oracle is, hey, after inserts on the order line table, do it for each row that's inserted, do this. And what we're going to do is we're going to update the items table. We're going to set on order to equal on order plus, and this is that new.num. So what happens is in our triggers, we automatically get these kind of new data sets, right? We get a new one, and then some we get an old one. So in this one, because we're doing an insert, there's no such thing as old. It's only new because we're only inserting new data. So we're saying set update item set on order equals on order plus the new.num order, because new is that new set of data. It's like a table, temporary table. And then num ordered is a column attached to that new, where item number equals, and then we're going to look for the new dot item number again. Now this one is, okay, now we're going to create a trigger on update order line. So before it was add, now we're updating the order line. So we're saying, hey, after update, so before it was after insert, on order line, same table, for each row, begin, we want to update that items table and set on order equals on order the new item number minus the old number orders, where item number equals that item number that we specified. So can you see here how we can use triggers? In this case, we are putting in information. We can do some aggregate information as well. There you go. So this one is now on the delete. Create or replace trigger, delete order line. So after deletes are done on the order line table for each row, begin, update the item, set on order equals on order, minus old number order, where item number equals old item number. Now, said all that, let's take a moment to go back and see what are we really doing here. What we've done is we've created a trigger that we can have a column that basically tells us how many items we have on order. So in this case, we've got a new product that just came in. Let's call it, this is, I think, was for toys, right? So we'll call it a bat. Get a new bat in. We're adding bat to our order line. And we're saying we got 10 of them in. So now, in the items table for our new bat, it's making the on order column the number we ordered. Let's say we did 10. Now, someone comes along and buys 5 of them. Now we're saying in this update, because an update occurred, we're saying on order is the number ordered minus the old number ordered. So we're updating that on order to now be 5, so that way we know we only have 5 on hand. And then finally, when we're deleting that item, we can put the on order minus the old number ordered when the item number is this item number. So we're basically getting rid of the number of items we had on order. This is the T-SQL version of it. What I find is when it comes to trigger, especially with this new and this old, sometimes SQL feels a little more easy to read. But what you're going to notice is there's a slight difference. So we're creating the trigger add order line on order line. We declare that the number ordered is a decimal. We're selecting the number order equals select number order from inserted. Update that item, set on order equals on order plus num board. So interesting enough, you don't really see any of those helper commands that we had like we have in Oracle. So there you go. So in this chapter, we talked about functions, which is the character, the numeric, and the date. There are plenty of others out there. Make sure you Google them. When we talked about concatenation, we use the right trim, and in Oracle, we use the pipes to say, put these two things together. We then talked about store procedures, and how a query is saved as a file that can be used to execute later. We have variables. We use the declare. This percent type attribute is, hey, use the same type as this column that we're showing you. And then we're going to say into clause with the select places results in the variables. So when we actually do our select, we want to make sure we're taking whatever data we're selecting and putting it into those variables using the into. We can do insert, updates, and deletes in PL SQL and T-SQL. Remember, access, not so much. In our cursors, we open, fetch, and close. Remember, in Microsoft SQL, we also deallocate. SQL commands in Access, we can create a string variable and run against the do command, run SQL command. And then we finally talked about triggers and how these are things that are done automatically, stored and compiled on the server, and executed in response to database operations. I'll tell you the most common use of triggers, and that is data logging, right? So I've created this nice database, and I know people are going to touch it, and they're going to do things to it. And what if I want to know who did what? One of the nice, easy, quick ways you can do that is you can create triggers that basically say, hey, for any insert, update, or delete, write what has happened into this logging table and tell me what was, if it's an insert, what was the new data inserted? If it was an update, what did the data look like before? What does it look like now? And then delete, what was the data we deleted? So there's a good example of a trigger, and it will always function because you've set it up to trigger on those events. So that is chapter 8. I know it feels like a little bit longer of a chapter. It's just a little bit more explanation needed, but things should go pretty quickly for you. And this is a reminder for most classes. This is towards the end of the semester, and so just make sure you may have due dates that are less than normal. Not all classes will, but most do. So just check, make sure you know what this week's due dates are. And with that, I thank you and hope you have a great time with this chapter.